Jono, Weakley, welcome to the Pacey Performance Podcast. It's an absolute honour and pleasure to have you.
Thank you very much. It's been a long time coming, Rob, and I'm glad to be here.
It's absolutely amazing to have you. We only caught up last week, maybe the week before, last week in Brisbane, and my little trip out there. So it's good to get together again. But for anyone that doesn't know who you are, Jono, before we get into the VBT chat, because anyone that knows your name, has come across your name, will associate you with your work in VBT, which is fantastic, and that's what we're going to dive into. But anyone that doesn't know who you are beyond that, would you mind just giving us a brief bio?
Yeah, thanks, Rob. So my name is Jonathan Weakley, Jono for short, and I am from the south of New Zealand, born and bred in Aotearoa, New Zealand. So grew up in Christchurch, ended up doing sports and exercise nutrition because I was adamant I was going to become a dietitian, like my sister. And I went down to Otago to do my bachelor's of sports and exercise nutrition. And then I got the opportunity to then go over to Wollongong, where I did my dietetics. And during that period there, I thought, geez, what would be really good and healthy for myself would be to do a second master's. So I enrolled in another master's in strength and conditioning at the same time. And then I was doing that strength and conditioning master's over at Western Perth. And then I thought, geez, my whole life I thought I was going to be a dietitian, but I realized I'm okay at dietetics, but I'm really good at the strength and conditioning stuff. And around that time, I was exceptionally fortunate to meet Professor Ben Jones and Professor Kevin Till, who were my supervisors for my PhD, and they took me out to the north of England, where I actually met you, Rob. I was saying earlier, I know, mate, that I met you on the same day I met my missus. And I did my PhD with England Rugby, and had the good fortune of doing a PhD embedded in professional sport, working with athletes each day, and also being able to learn from those athletes and also do research which wasn't only interesting, but was also really useful. I was very, very fortunate to take on a postdoctoral position with RFU, and then probably after 5 years in the north of England, I was starting to look a bit pale and a bit ghostly, so I went home to what I call now home is Brisbane in Australia, where I work at the Australian Catholic University here. So it's based in Australia, but as you know, I do a fair bit of travelling around most of the time now, between US, Europe, and Australia and New Zealand, consulting and researching and working with sports teams. And this is me now back at Australian Catholic University.
Not as pale and not as ghostly. Got a little bit more, a lot more colour about you.
Yeah,
Unlike me. Right, mate. So let's dive. So thank you for that. Let's dive into the VBT stuff. So velocity-based training is not new. We all know that. But where has it come from, and where do you think it's going?
Yeah, it's it's a good question, and where it's come from and where it's going. I think first and foremost, we probably need to establish what it is and what it's not as well. So, as you said, it's not new. Athletes and coaches have been using VBT for decades, and coaches have known that it's important to expose athletes to a range of velocities as they exercise, which is determined by the load on the bar. And because we know that sport is completed at a range of velocities. You've never seen Lionel Messi or Ronaldo or Richie McCaw do a 300 kilogram back squat or deadlift in the middle of a game. No, they exercise at velocities. So the thing is that we know that we need to exercise across a range of velocities, and we need to nip the idea in the bud that it's actually something new, because Soviet strength coaches back in the day, we're talking about strength speed and speed strength, and think about things like West Side Barbell. They talk about dynamic effort days and training at 0.8 meters per second. And all of this stuff was going on far before I was born. It's probably going to be going on far after I leave. And it's something that's been implemented in sports, in sporting environments more and more so recently, because it's just now that the technology is becoming more available, and the masses are able to say, hey, I'm not like every other athlete. I am my own person, and I need individualized training. And so now we can start to use this technology to actually help work with sporting teams and complete research or whatever it is that you want to do with it. Second of all, I think VBT is not a method that must work in isolation. is made to work within a training program and be tapered up or down depending on the context of that sporting environment. So, for example, during a power phase, you can provide feedback to athletes to enhance the velocity of the bar as they're exercising, and you can help drive greater intent with that velocity feedback. And that's velocity-based training. But we also know that you can monitor testing, like you can implement velocity-based training in testing batteries. So we could set an athlete a set load and test them across 2 points and see if their performance improves by the bar moving faster over time. Because if the bar moves faster, that means they're getting stronger. And to be honest, maximal strength is quite a crude measure. Realistically, we need to be performing submaximal efforts like we do in sport with maximal intent, or submaximal loads with maximal intent. So we can actually use velocity-based training in testing. Additionally, you can modify training load based on things like arbitrary thresholds and cutting off a set to dictate the volume and ensure proximity to failure is appropriate no matter when you're training. And all of these methods can be used with other methods. That could be with an RPE method or a percentage-based method or a reps in reserve method. But all of these velocity-based training methods can be implemented and aren't made to be working in a silo. And finally, and the amount of hate mail I get about velocity-based training is kind of astounding because people are so wedded to their beliefs. But it's not some sort of VBT Illuminati sort of like gig. It's not like Brian Mann, me, Amador Garcia Ramos, like sitting at the VBT convention each year having a laugh. It's a method that we use with sporting teams and coaches, which is fundamentally based in physics, biomechanics, and physiology, just like all training should be. So that kind of then takes me to what is VBT. And VBT is a method that uses velocity to inform or enhance training practice. And as I said, it doesn't work in a training silo, and it works with other training methods to enhance our training practice. And why it works is because it's based in 3 fundamental tenets of training. So we know first and foremost that as barbells get heavy, barbells go slower. It's really, really hard to move a barbell quickly if it's really, really heavy. So that gives us an idea of intensity. We also know that as we get fatigued, barbells go slower. So, your 10th rep is going to be slower than your first or second rep because you're fresher on the first or second rep. And the third tenet of velocity-based training is that there is a terminal threshold where you cannot exercise for each exercise. So, for example, in the back squat, you can't really squat below approximately 0.25. We're not able to as humans. It's possible. And the bench press is about 0.13 approximately. There's a little bit of give and take here. For the prone row on the bench pull, people can't exercise below 0.48 approximately. So what we now have is if we know that there's a point of failure and you can't exercise below that, and that is the point of failure, and you know that as barbells get heavier, barbells go slower, and as people exercise, the barbells go slower. Proximity to failure and where failure is going to occur so that you can ensure that the training stimulus is appropriate for the athlete. And so that's VBT, and you can use all these methods with all your training programs throughout the year. And where it's going to go into the future is that realistically that we're going to understand that it's 2023 and furthermore we should be embracing our athlete differences. And that we should be accepting our athlete differences and using some of this information to ensure that our athletes have their training programs individualized for them based on their own capacity. And a classic example of this, Rob, is that, and I'm going to tell you a little secret here because I don't know how much people know about this sort of stuff, but it seems pretty common sense, is, those little tables in the NSCA textbook where it say, 10 reps at 75%, 12 reps at 70% and 15 reps at 65%. Well, there's over 300% variance in those numbers. So I might have an athlete who can complete 15 reps at 75%, but I might have another athlete who can complete only 7 reps at 75%. It's because athletes are often genetic freaks and they're trained to be freaks. And those tables are based on average data, but I'm not working with average athletes. I'm working with the best. I'm working with the greatest, and I'm trying to individualize to ensure that the adaptations are appropriate and the stimulus is appropriate. So what we're trying to do with velocity-based training is help individualize a little bit better and ensure that the feedback or the information that we're using in our training is helping to maximize our training programs, training performance, and training adaptations. And as people start to embrace this idea that velocity can be useful, it's not trying to take away from all the great things that we've done in the past, but it can inform and enhance our training. I think that's where VBT is going in the future. And you see nowadays that sporting clubs, schools, individual athletes, they're all using these tools, things like gym wear, perches, push bands, and these all help monitor training loads and training volumes and intensities. And I think that people will start to understand that, it's not either or, it's not percentages versus velocity-based training, it's percentages and velocity-based training, and we're working together to make our athletes better. And I think that's really what we're seeing. And let's be honest, we're seeing all of this velocity-based technology being implemented at universities, being taught at universities, and also clubs implementing it. So I think the next generation of strength coaches will have a really good grasp of not only what we've historically known about, train at X percentage of your max or do X reps, they're also going to start implementing velocity into their training programs. And it makes sense, doesn't it?
So good, Jono. Very, very slick, as I knew it would be. So hate mail. Why are you getting hate mail? I love that.
Mate, I swear down. I once went to a conference and I presented like a 10-minute kind of a topic once, and I got followed out of the conference and just like accosted. I genuinely, this person's quite established individual, and we had to tell him to calm down and go take a breather. It's just like, as people are so wedded to these ideas that, velocity-based training is this or that, or we've been doing that for 20 years. It's like, nah, man, like, come on, bro. We're all trying to improve our athletes' performance, and it's not taking away from all the great things and information that we've had in the past. Like, I read Zatsiorski, I read, Matveev and all those sorts of texts. I like, like, I'm trying to learn Swedish at the moment so I can learn about more of the Swedish strength and conditioning coaches. And the thing is that none of that takes away from that previous information. Actually, those coaches were talking about those aspects. But the thing is that now we've got the technology to actually monitor this, the velocity as we're exercising, and these kinetic and kinematic pieces of information, so that we can actually improve our athletes' performance. And I'll also add that it's sometimes really misleading, because people often don't know what velocity-based training is, and they say, we did a meta-analysis, and for anyone who's listening doesn't know what a meta-analysis is, it's where you combine all this information into one topic. But velocity-based training cannot be meta-analyzed. It's so many different topics that you can't just squish it into one paper and say, they all do the same. That's just as effective as something else. It's because you need context and you can't just throw, we used VBT to compare to percentages, because there's so many different aspects of VBT. So we need to use that VBT in context, because it's extremely powerful when you use it contextually correct.
Did you have a similar T-shirt on when he accosted you outside the conference? Because if you did, he's a brave man. He's a brave man.
When you're 5'7" and Māori, bro, it's pretty easy. It's pretty easy to look like I do, bro. It's but the thing is that it was pretty confronting, and it was interesting, because I'd grown up looking up to this individual, and and it was a dismay. I was quite dismayed to kind of see that. But I was surprised that people were so passionate about this topic, because at the end of the day, we're trying to improve our athletes through physical development and through proper training, and having more information doesn't take away from that. If anything, it adds to it. And so I was quite surprised, and some of the messages I get on social media and over email are always interesting, and peer reviews are always a bit of a struggle.
do you think, because people are married to one particular thing, and they think velocity-based training has to be the whole package, influencing every small decision within a program, versus, like you say, just complementary to your traditional percentage-based training?
Yeah, absolutely, mate. Absolutely. And, like I worked with, a Great Britain sprinting athlete, unbelievable athlete, was springy as anything. And I had the privilege of working with that individual 3 times a week, one-on-one in the gym. And yeah, great. We could use velocities to guide pretty much every decision, because we know that as barbells go slower, there's either fatigue or the barbell's getting heavier. And the thing is that I know I need to expose this athlete to the range of velocities as they exercise. So I could just program based off those velocities. So ensure the barbell was getting heavier each week and the barbell was slowing down even as they were adapting. So we could ensure that the training program was always correct for the athlete. But the reason I got into velocity-based training, and this is quite a story, and I think most coaches have these stories, but I remember staying up till about 4 a.m. one morning, and I had coaching at about 6 or 6:30 in the morning. And I had these pristine training programs, and they were 3 sets of 10 or 4 sets of 12, or all that sort of stuff. Can't remember, but all the boys came in, and some were a bit banged up from the weekend from the game on the weekend, and then we also had some athletes who were fresh, and despite my best laid plans of doing 10 repetitions, some were only able to get 5 or 6 before they were failing. Other athletes were saying, "Coach, is that it?" So what I started to realize was that actually there was this flux of wide groups of athletes, and I just needed to find a way to help monitor and guide their training a little bit better. And this is where VBT really started to take interest for me. And so I started just using feedback. I had 45 athletes in the squad, and I was one person on the ground. And I knew that if you had more supervision, where this is well established throughout the literature, greater supervision as individuals train improves physical adaptation. So how can I increase this supervision when I'm just one person? Well, I could put a gym aware on every single rack, and I could ensure that they're getting feedback. And then I could look over those numbers as they were training, and I could look back at past sets, and I could have greater conversations with these athletes. But on top of that, we also started to realize that, hey, these barbells are moving faster because they're getting the feedback, and boys are starting to get wild in the gym. They're more motivated and they're more competitive. And that's where we started to really delve into this feedback element, that athletes were starting to use greater intent, and that indeed our training performance was improving. And guess what? We ended up doing a training study and showing that if you provide them feedback chronically, they adapt even more than athletes who aren't being provided feedback. Everyone's improving, but one group of athletes are improving even more. So that for me was really where it started. And that's a completely different situation from 45 athletes in a squad to one athlete one-on-one. The thing is that you can be a great weightlifting coach, you can be a great powerlifting coach, you can be a CrossFit coach, and you can use different elements of VB2 to inform your training prescription. If you're a weightlifting coach, you might say, all right, we're going to have like clusters, and you're going to terminate a set once it hits a certain velocity. For a CrossFitter, you might say, hey, we're going to focus on muscular endurance, and we're going to focus on power endurance specifically. So we're going to try and get as many reps out before you hit a certain cutoff. And on top of that, you might say, I'm a bodybuilder. Well, that means you might only stop the set once they go below a certain threshold so that they're in close proximity to failure, because we know that proximity to failure is important for muscle hypertrophy. So you can use it in a range of different ways, and it might just be that you're providing feedback for them. But what we can show is that you can use this information to better guide your athletes and stimulate conversations as well. So yeah, and I think and probably the simplest form of VBT, which is feedback, is the most effective. And we did a big
how effective? Yeah. Oh, Scott, mate, you're gonna answer the question before I.
Yeah. Just let me go, man. I'll just talk for 45 minutes. But I think how effective is a good question. Well, 8% on average, 8%. So there has been so many studies on the effect of velocity feedback as people exercise across more than almost 30 years of research. And there's never been one study that has showed that the provision of velocity-based feedback decreases or has a harmful effect. Every single time it's shown a positive effect. And that's incredibly hard or rare to see in the literature because there's so many different contexts. And we showed that every time that athletes are being provided feedback, they improve by a certain percentage, and on average it's 8%. The crazy thing about that is, Rob, I train athletes for 3 to 5 years to get 3 to 5% improvements. You know what I mean? So if I can have instantaneous improvements of approximately 8% and improve performance by a huge amount, well, I'm an excellent strength and conditioning coach all of a sudden, you know? And it's so simple, just by providing a little bit of feedback. But the cool thing is that we're not just interested in acute performance, because it's really cool that I can lift a barbell faster and put out more power. But the thing I'm really interested in, this is what coaches should be interested in, is that how does it transfer to physical adaptations? And well, if you provide athletes chronic feedback, so over a training cycle, they get feedback chronically across all their exercises, you see greater chronic adaptations. So we know that as athletes train, we see improvements, but the improvements with feedback is even greater than normal training. So all of a sudden, by providing basic feedback, athletes are improving to a greater extent. And we've seen this in jumps, sprints, strength exercises, and we just did a big systematic review and meta-analysis, which doesn't sound like the most interesting thing to do. But geez, when the findings are that clear, it's really interesting. Because all of a sudden, we've got the simplest tool making massive differences for our athletes. And every single study to date has shown a positive effect. Not once has there been null effects or harmful effects. Everyone is conclusively seeing positive effects.
So for the last 20 minutes, I'm sold, right? If you're selling VBT, not that you are selling VBT, but if you were selling VBT, I'm buying. So, and this is one thing we spoke about when I was over there last week. And this is just from my environment, like working in football, going into football clubs, maybe less so rugby clubs, but and only in the UK, by the way. In terms of adoption to velocity-based training, it seems to me that based on what you've just said for 20 minutes, like it's a no-brainer. It's a no-brainer for everyone. So why hasn't it become a no-brainer for everyone? To me, and this is just looking at trends from speaking to people, social media, articles, research, it seems to spike. It seems to ebb and flow, as a trend may do. But why isn't it? It doesn't feel like it's like embedded completely, even in the environments that seem to revel in it. It seems to ebb and flow. So what's your thoughts? Is it just my bias from what I'm seeing, or is that the state of play?
Yeah, no, it's a good point, mate. Well, let me put it like this. It's a really good point, and I think that there's a couple of things. You know, like I think bias is a fair thing. You know, if you're looking for it, you often see it. It's like when you learn a new word and you hear it all the time. All of a sudden, it's because before that you didn't know about it. And I think I would probably counter that with the point that I haven't been into a professional sporting team in years, and not seen accelerometers, linear position transducers, camera-based systems. I see them everywhere. I'm a Kiwi. I love watching the All Blacks and all that sort of stuff. But I look on their Instagram, and Nick Gill's got the gym wearer out, and the barbell's going up and down, and the boys are reading out velocities. Yeah, I see that because I'm looking for it. But even let's go to a level below. Like I work with a range of professional sporting teams, from the top of the tops down to community level sport. And I went down to a club the other day, a rugby club, and they had gym wears. They had technologies which were monitoring velocity. Furthermore, I work with sports teams. We've got PhD students who work with sports teams who are based at high schools. They've got gym wears, And on top of that, I work at a university. We have whole weeks dedicated to velocity-based training, and that was before I came. That was well before I came, mate. So the thing is that it is everywhere, and the technology is everywhere. It's just often, you're right, it ebbs and flows, and people often don't know necessarily how to implement it, or they don't know necessarily that they're doing VBT every single day. Because VBT can be so simple. It can be as simple as just providing feedback to the athletes, or monitoring changes over time, or saying, you improved by X amount on this lift. See, this is all velocity-based feedback. Velocity-based training. And I think it's far more common than people are willing to kind of almost acknowledge. It's everywhere. It's just that when you're looking for it, it's far more common, I think. And yeah, I had a meeting with a netball club today, and they telling me, they had 3 gym awares and they were doing trap bar jumps with it. And I thought, great, that's VBT right there.
Yeah, nice. Well, so you mentioned a few in the first section, using cutoffs, et cetera, and you had a nice little figure that I sent. Obviously, you've seen it many, many times, but I sent it to you anyway, and so I'm going to reference this. A figure continuum, less use of velocity, greater use of velocity. Would you, and there's a number of things, 9 things on that continuum, in terms of the different ways that we can use velocity-based training. What are the most widely used? What are the most, we've touched on feedback, obviously that's one of them, huge. What are the other pretty more technical ways that we can use VBT that are most used, most beneficial, most easily implemented?
And again, it completely depends on the athletes that you're working with in the context of your environment. So again, going back to my time in rugby where I had 45 athletes, I might have 1 intern or 2 interns, and you can kind of overdo it with interns. We see that all the time. But the thing is you need people you trust as well. So what I found was I'd say I'd get on a box. I'm a small fella, so I'd stand up on a box so everyone could see me, and I would say, all right, lads, we're doing 4 sets of 10. If the barbell goes below X velocity, just rack the bar for me, all right? And that was my way of controlling the fatigue so that they weren't going to failure, or they weren't just grinding out really slow reps. And it was just a safety measure that I put in place. The boys understood it. They went, okay, cool, I got it. Again, things like feedback are really simple, particularly during like power mesocycles. Alternatively, during preseason, where we would have a real focus on like development of muscle mass and muscular endurance, I would say to them, all right, lads, we're doing 4 sets. The barbell can only stop once you get below a certain speed. And we ensure it's an aspect of proximity to failure there, and we know that the individual is being stimulated. Alternatively, and this is something that's always amazed me about strength and conditioning, is that when you test, you're often in a standardized fatigue-free state, right? You have the weekend off, and Monday, lads, we're going to go do a 1 RM back squat. But when you train across a mesocycle, you're not fresh because you've been training on the field, you've been just doing multiple sets and things like that. And we can ensure that we can use their load velocity profile to monitor the loads. So for example, if I know as an example that an individual should be squatting around 0.7 meters per second at 100 kilograms, and I can see that they've had a field session and they're squatting about 0.55 on their first rep, I'll say, look, mate, let's just take 5 kilograms off each side, make sure the load's appropriate for what we're trying to stimulate and we're trying to target, and we'll still do those 10 reps that we had prescribed or whatever it may be. It helps guide discussions. You know what I mean? It helps us go, hey, why are you squatting at 0.55? Why are you lifting that speed? Because that testing session, which was a month ago, which is, let's be honest, probably no longer relevant because they've done a whole lot of field sessions or they've adapted and gone stronger over time. How many times have you worked with an athlete and gone, oh, we're going to have to put the weights up by 10 kilograms across every lift? Yeah, because that's adaptation. No brainer, right? But the thing is that it helps guide those conversations, ensure that the loads are consistently appropriate across the training mesocycle. And you can just use those velocities to help guide our training decisions. Because if you've got 100 kilograms on the paper and it says 4 sets of 100, like, the paper isn't my boss. You know what I mean? The training program isn't my boss. I'm trying to make sure the athlete is adapting as they should. So I want to make sure the load is appropriate. So even just basic conversations. Hey, that barbell's moving a bit slow today. What's going on? I've had more good conversations start from having a little bit of velocity feedback than I've ever had, from just eyeballing barbells going up and down. You know what I mean? Because I have so many more eyeballs kind of available because I've got all these iPads or tablets going in the gym where I can see the velocity feedback, and I can start a conversation with the athlete. I go, hey, what's going on, man? Why aren't you performing like you usually are? Something's wrong. Or, hey, you're looking good. Let's chuck 5 kilograms on and see if we can really push this boat out and see where we can go. But there's so many different aspects, and it really depends on the context. And as I said, you can taper it up or taper it down on the context. It's never 100% VBT. It's like that, like saying never go 100% VBT. You know what I mean? But in reality, it's made to support and inform and enhance the training process. It's not one or the other. It's never one or the other. And you can use RPE and VBT and a little bit of percentages all mixed together. It depends on your context.
Don't blow people's minds yet, Jono. Saying they can actually use one or the other. They can use both or all of them. Yeah. So Jono, the terminal velocities of each individual exercise, like you mentioned, do we, especially those, because the majority of people listening will have, I'm guessing, will have large groups to deal with and probably not tons of tech. Is the individualization of that terminal velocity something that people should be worried about? Or should they take numbers in the literature and use that as the guide? Because how much individualization is there?
So you might say in the back squat, for example, let's just use common exercise. Everyone pretty much does. Some people might be able to squat 0.27. Some people might be able to squat 0.23. But we're talking about like 0.02 meters per second. And the thing is that people great work has been done by people like Amador Garcia Ramos, who have established all these velocity, like terminal velocity thresholds and exercises that are freely available on the internet. You can just grab them and just go, okay, here's the proximity to here's the terminal velocity. Let's make sure that we're either close or far away from it, depending on the physical capacity that we want. And there's some great research about how if you go further away or closer to failure, you can actually stimulate type 2 or type 1 muscle fibers. Really, really cool stuff. And that was the stuff that really made me go, all right, I'm gonna get my academic hat on and dive into this sort of stuff. But this information is freely available, and you can just Google it. You know what I mean? I think in my 2021 paper I provide them all. So the thing is that it is available, and the individualization has, some people might be able to squat 0.26 and someone's 0.24. But if that's the thing of having a good day and a bad day, we need to get our priorities in order, eh? You know what I mean? It's 0.02 meters per second shouldn't change our physical adaptations by that much. So yeah, if you're training right to failure, what does it matter anyway? You know what I mean?
Do you think, just looking at this figure here, so velocity-based training continuum, highlighting the various emphasis on velocity within a training program, because there is 9 things there, do you think that sometimes makes people a little bit overwhelmed, thinking velocity-based training is this big thing that I'm trying to wrap my head around, when actually picking individual things that work for you based on the, your environment and your group and your what adaptations you want? Do you think that sometimes gets a little bit overwhelming?
Yeah, for sure, and it's, I'll raise my hand.
Not your fault, by the way.
Yeah.
I wasn't pointing fingers.
Yeah, I thought I did a good job.
You did an amazing job.
You're right, mate. And let me put it like this: when people had, when S&C and resistance training was starting to get rolled out in university and textbooks were coming out, and people had been taught about velocities of bars rather than percentages from a previous max, people would go, yeah, that's a no-brainer, because people adapt or get fatigued over time. Velocity is velocity. It's always the same. You'd go, yeah, why are we using that thing from 6 weeks ago, which is no longer relevant? What about that barbell that's going up and down, and we know how fast it's going? Everyone would just use that, but because we've been taught one paradigm, and now we're trying to say, hey, let's change that paradigm to implement some velocity aspects. Yeah, it can be really overwhelming. And geez, I do papers and sometimes I'm reading them and going, I don't even know if I understand what I'm saying here. But I think as long as you get the basics down and understand that, you can taper it up or down, and you can ensure appropriate physiological responses, I think it should be relatively simple. And I think the easiest way to kind of dip your toe into the old pool of VBT is just providing basic feedback as athletes to train. But there are some amazingly complex aspects of VBT as well. Like, for example, we know that through prescribing relative velocity loss thresholds, so for example, if I do a 10, 20, 30% velocity loss threshold based off a certain set point, we can induce the exact same physiological response time and time again. Now, when you think about this, now I'm going to get a little bit complex here, but if you do 5 sets of 10 at the start of preseason, you're often quite sore. But by the end of preseason, if you do the exact same training program, exact same percentage, relative percentage of your maximum, same number of repetitions, same number of sets, you're not sore because you've adapted over time. But the thing is, with prescribing relative velocity loss thresholds, we had to do this really intense project where we were showing that, hey, if you prescribe with a set velocity and terminate them at set velocities, terminate the set, the physiological stimulus is exactly the same because they're in identical place or proximity to failure. Bro, that's amazing. There's an amazing finding, because I don't care if you can prescribe something once. I care if you can prescribe something and do it time and time again. Another analogy could be like, imagine if I went to a doctor and I said, I've got a headache. And he said, okay, cool. She gave me a Nurofen. And I said, so 2 of these? And she goes, yeah. It might cure the headache or it might kill you. I'd say that's a bad doctor. But, we don't do that because in medicine and when we prescribe with medicine, we ensure that the response is always the same or tries to be as similar as possible. But in S&C, we forget about that similarity. You need to be able to prescribe something, ensure the response, and then do it later on in the year and prescribe the same thing and have that same response. And velocity-based training or prescribing of relative velocity loss thresholds is the only way we can do that I've ever seen in the literature. There's only been a couple of studies here that ever employed those training sort of models. But, that's an incredibly complex, kind of mind-blowing concept to get your head around. But providing just basic feedback, barbells go zoom, geez, that's really simple. Improve your motivation. Damn right. Yeah, damn right, barbell wins zoom. I'm going to lift it faster next time too. You know what I mean?
Just on the velocity loss thresholds, can you give us a bit more, like, how are people using them effectively to get different adaptations?
Yeah, for sure. So, for example, and there's heaps of different ways we can implement them, but you might start at a set speed. So you lift the barbell up and it goes up 0.7 meters per second. And we know that if you go closer to failure, you're going to induce more muscular hypertrophy because you're going to be completing more volume. But you're also going to be causing those muscles to have to, be more endurance focused, if you know what I mean, because you're having to do more reps, more volume, closer to failure, slower reps, more muscular hypertrophy, more endurance orientated. But on top of that, we could do a smaller velocity loss threshold. So rather than doing, say, a big velocity loss threshold of 30 or 40%, we might use a 10% velocity loss threshold. And what that does is ensures that the barbell doesn't go too slow. It ensures that velocity stays high. And because we know velocity times force equals power, we know that our power stays high. And we're training our athletes to be powerful. It helps our athletes, to recruit different muscle fibers, motor units, and ensure that the quality of the session stays high. So you can implement different velocity loss thresholds based on what you want. If you want a real big metabolic physiological stimulus, great, put a great big velocity loss threshold, 30% threshold. And that's going to drive a different adaptation than if you're going to use a 10, 15% velocity loss threshold. So you can have these divergent responses, even though you're lifting the same bar or the same load, by basing off when you terminate the set or how much volume you do. But that makes sense, right? Because sometimes you've got to do power work with heavy bars, sometimes you've got to do power work with light bars, but it's still power work. You know what I mean? If you want to do a hypertrophy set, you can still use a heavy bar or a light bar. It just means you've got to go to close to failure. So the thing is that we can terminate sets using velocity loss thresholds to kind of preferentially cause adaptations that are desirable for our athletes.
One thing that we haven't touched on, you've mentioned a couple of different technologies, and this is something that I'm interested in based on your experience, because there's probably not many people around who've got the experience as a coach, as a researcher, but also within the tech that's available and diving into for various different reasons there. We had gym aware has been around for a long time. Push kind of came and has disappeared because of various, not because of them, but obviously the acquisition, that's disappeared. And then we've got other camera-based technologies that have been developed and have kicked on, and you mentioned Perch being one of them. Where are we at with the technology that's available for VBT?
Yeah, it's a good question. And as you said that, my mind kind of immediately thought that there's kind of four main categories, if you will. You've kind of got linear transducers, so things like the gym wear. And I say linear transducer because there are linear position transducers and linear velocity transducers. And while they're different, they kind of do the same things, and they kind of look the same. They have a tether, which connects to the barbell. And the strength of those devices is that they have a direct measure of displacement. And when you have a direct measure of displacement in time, you can very accurately calculate velocity. And with that technology, if you've got a very accurate measure of velocity, it means that you can use the whole gamut of velocity-based training because everything is accurate. So that's a real strength. That's a real strength of them. A little bit of a con, because everything has strengths and weaknesses, right? So one of the weaknesses is that you've got a tether connected to the barbell. And some athletes don't necessarily like that. I've never had a problem myself, but some weightlifting athletes, when they're particularly doing Olympic weightlifting, the bar's coming from overhead down, and they're worried about slamming, a couple of 100 kilograms into a linear transducer. Yeah, that could be a con because you're not going to have that linear transducer for long. But that's the reality of it. So you've got this probe, great accuracy and amazing ability to monitor volumes and intensities. But it's also got to be attached to the barbell. But then you've also got accelerometers, and I kind of touched upon this in a 2021 paper where I talked about all that, the strengths and weaknesses of all the technology on the market, or the validity and reliability, and we showed that kind of the validity of accelerometer-based units aren't quite where they need to be. And you stated push before, and push was an accelerometer which you put on the arm. And we found that as the barbell went faster, it got more inaccurate, which is real alarming because you want to use those devices to be accurate. So accelerometers have their weaknesses in some ways because they can be a little bit of a random number generator at times. They have their strengths, which is that they're not necessarily attached to the barbell; they're attached to the individual, but you suffer with inaccuracy. Alternatively, we have this two kind of growing areas as well. You've got camera-based systems, which are, again, like Perch and Elite Form, and they're showing real great promise. And one of the strengths of them is that nothing's connected to the barbell. Hell, it's just sitting up on the rack. It's just watching you as you exercise, and the barbell's going up and down. It's giving you feedback and it's giving you numbers. That's excellent. However, what we're seeing with some of this camera technology is that you are slightly limited by the frame rate. So, if you've got a really good high-speed camera in the system, you can then have really accurate measures of velocity. However, if you've kind of got a slower measure of a slightly slower camera, you might be able to capture those peaks as easily. And the issue with that is that a lot of exercises need to use peak velocity rather than mean velocity. Peak velocity for Olympic weightlifting, ballistic exercises where you go up in the air. You need to use peak because you don't want to monitor the time when they're in the air because they're not doing anything. So that can be a limitation itself. Furthermore, that if the field of view isn't very big and you've got someone like you working someone like me on a rack, then you might be able to go, okay, Rob's taller than me and he's doing an overhead press and the bar goes out of view. That's a limitation in itself. But that's okay. So there's some great strengths there because there's nothing attached to the bar, but hey, you might suffer with some accuracy or losing the monitoring of the bar. And finally, there's another device called Flex, which uses optic laser system. And they come out, and they're actually made by the same makers of gymwear, so Kinetic Performance, both those from Canberra in Australia. And they use a direct measure of displacement as well through the laser. It's kind of like your builder or your tradie, how they've got a laser pointer and they can assess how far away something is. Well, that uses the same system. However, and that's great because it's really accurate. And hey, it's on the bar, so nothing's attached to the bar, which is then attached to the ground, so no tether or anything. It's not going to fall off. But the issue is that that laser system then has to hit a reflective mat. And I think, despite us working with athletes and them being amazing individuals on the field or on the court or on the track or wherever, the issue is that often in the gym they're not that graceful, and there's people bumping into each other and plates going everywhere, and the mat's getting kicked to the side because someone's trying to put some bars weights up on the side of the rack, and you kind of then sometimes see athletes who forget to train over that reflective surface. So there's strengths and weaknesses with everything. And I think it's really horses for courses. How much accuracy do you and your club need? What is it that you're trying to do? And maybe is it what sort of exercises as well? Or how often are you implementing this technology to monitor and prescribe and enhance training performance? Because all of these decisions dictate what technology that you end up choosing.
I'm not going to throw you under the bus here, but I'm going to ask you, what do you think's got the most longevity and potential for development in terms of those four categories that you've mentioned there?
Yeah, this is a hard question because, I'm
clicking that pen as well.
Oh, sorry, mate. Sorry,
no
sorry, bro. I just realised. It's a really good point. Sorry, mate. That's a really good point, bro. I think. Yeah, I'm going to play a real political answer here, and because I'm going to make a lot of people angry or upset, and it's not what I want, because all this technology is quite amazing. But what I'm seeing on the market right now is that the GymAware is probably the most accurate device in sports technology in the world. We've got accelerometers that monitor stride rates as people are running around on the field. That's cool. But stride rates are quite hard to detect and all that sort of stuff. There's noise, there's variability, I get it. Then you've got GPS systems which are triangulating people on the planet through satellites floating around the world, and that blows my mind. But they triangulate them within a couple of meters, and that's pretty cool too. Amazing. But then you've got linear transducers which are detecting barbells within millimeters, and that's an amazing feat. And in my experience in strength and conditioning and sports science, I've never seen technology which can be that accurate and that consistently accurate. So that's remarkable. Probably, and so it's really hard to improve long term if you're that accurate to begin with. However, so I think some of these camera-based systems are remarkable as well. And I think as the technology gets better, as the software engineers, the hardware engineers can refine these products, that these linear transducers are going to have to look over their shoulders, because these camera systems are remarkable. The technology is still developing. The accuracy is still getting there. But just like everything, technology improves over time, and it'll be a pretty fierce market soon if it's not already.
Do these camera-based systems detect the particular exercise that the participant, the athlete, is actually performing without having to be on screen?
Yeah, they can. They can do that. Not all camera-based systems, and I think it's something that a lot of it's kind of machine learning, isn't it? Like there's certain ups and downs and bar displacements which are specific to a certain movement, and then I think they can actually start to detect these movements as the individuals are exercising. Because in a perfect world, what we want is the individual to go in there, do their training session, not have to fiddle around, and just be given all the advantages with which velocity-based training gives you. Are we there yet? Not quite. But over time, I think we will. And I'm working on projects which do similar sort of stuff like that right now.
How close are the camera-based systems to the GymAwares of the world?
Accuracy-wise?
Yeah, accuracy-wise, and I suppose confidence from yourself as a researcher looking into these products, and people asking you, Jono, what should we go for? At what point, how far away are we from you going, take your pick, because in terms of accuracy, they're there. Yeah. It's there.
I think the most to be fair, the most accurate device on the market are linear transducers, and most impressively is the GymAware. They are exceptionally accurate, and they're hats off to people like Evan Lawton, who came out of the AIS from back in the day, because he's developed a product with one of his colleagues, but who are incredibly accurate. I think it all comes down to, though, what you want to do with it and how much accuracy you need. Because I think, like, if I'm in the lab and I'm trying to, do a assessment where I'm, like, as I was saying before, with relative velocity loss thresholds, I'm taking people's blood and I'm trying to see changes in, lactate or hormones or whatever it is that I'm trying to do. Well, I need, like, pinpoint accuracy. But the thing is that if I'm just, like, working with a group of footy players and then we're trying to get some feedback to improve our performance, then, hey, as long as it's systematic, it doesn't really matter. But I think a lot, these camera-based systems will be improving over time, and I think it's I'd be surprised if they weren't kind of elbowing close to the linear position transducers in the near future.
Happy days. So my last question for you: what's next for you in this area? What's next in this area generally?
Look, man, I think, like, as I said this, I think in my opening rant, and that the velocity-based training, all of the work that we do can't just be interesting. It has to be really useful as well, because I don't care if it's interesting. If I can't use it, it's not useful for my athletes and the people that I consult for. So the thing is that there's been a few projects which have been going on. The first and foremost is that and my students are gonna. They always say I kind of try and shine the spotlight on them excessively in these moments, but I'm so impressed by the work they do. People like Nick Cowley out of ACU here, he's doing work where he's comparing velocity-based training, rating of perceived exertion, reps in reserve, and percentage-based training. And he's showing that, hey, what are the effects when we compare all these methods? Okay, there's big differences in kinetic and kinematic outputs, big differences in fatigue, big differences in subsequent like performance within session and as they recover over time. How people perceive it, how people enjoy it, and all this. He's done a monster study, this lad, and it's kind of showing, hey, that if you want X, you should choose this thing here, or if you want Y, you should choose this training protocol here, or this training method here. And I think that's going to be a really, really cool study in the near future that's going to come out. And fortuitously, I've the data. I've just seen the data, and it's pretty exciting. And I think it's exciting, at least. That because you go to any bodybuilding forum, any weightlifting forum, any strength and conditioning environment, and people are arguing about, I use RPE, or I use RIR, or I use VBT, or percentage-based training, or whatever it might be. But we don't have a definitive answer because no one's ever compared them. So that's a really cool study. I also think there's some great research from like people like Tandy Wood, who's going to be doing some feedback work. And also we've got some work with female athletes, because we know that females are underrepresented in sports science, and we need to start correcting some of these issues that we've had and neglecting 50% of the population. So some of the work that people like Gabby Montiano are doing around training across the menstrual cycle, and looking at how we can manipulate training loads based on fluctuations in hormones. And I think, and we're monitoring all their velocities and performance within sessions, but we're also doing comprehensive like dietary analysis, sleep analysis, changes in physical adaptations across every training session. DEXAs, ultrasounds, strength adaptations, isometric, dynamic, everything under the sun. And we're monitoring these females as they're training and adapting their training through, their hormones, through traditional prescription, and also through auto-regulation. So I think that's going to be a really, really cool study. In some ways, I think that's probably going to be the most impactful work I might ever be involved in. So, shout out to those kind of 3 students who are absolutely killing it. And I'm incredibly proud of them as well. That's
a big shout. That's a big statement, but I love it. So is anyone that wants to get involved and get to read your work, where's the best place? Anything on ResearchGate?
Yeah, pretty much. Yeah, ResearchGate. Hate mail at robpacey.com. No, I think I love hearing from people. I'm far more accessible than people I think often realize, so that they can always email me. You can reach out. I think I once did a podcast or something similar with you once, and you said, "You don't have an Instagram?" And so I went and got an Instagram. So Jonathan_Weakley, I think _PhD. And so they can also DM me or something like that. That's fine too. But all of this information I try and make as freely as available as possible, and try and be accessible to people, because at the end of the day, we're just trying to improve our athletes' performance. So we should be accessible. We should be facilitating these discussions. So of course, my email, you can reach out on email, or but things like ResearchGate is always a safe bet for the actual papers that I'm publishing.
Perfect. Well, Jono, as always, it's an absolute pleasure. Thank you for the last hour and a little bit, and look forward to catching up hopefully in Brisbane soon.
Yeah, anytime, man. It's definitely a bit warmer out here than old sunny Leeds.
It is, mate. It is. Well, thanks a lot. I'll let you go. Thanks, mate.
Thank you, brother.
Cheers.